everyone. I want to run through a handful of examples here to get you started. So remember that the first 3 pages of your activities packet, those are all examples, and they actually get pretty messy. But I find that sometimes people sit down to start this homework and they're fairly easy at the beginning and it just kind of throws them. They're looking for this big mess. So let me talk to you about how I pick these apart. Okay, so I have the derivative of 4x plus 1 to the 8th. So this is all about what is the last thing happening, what is the big operation. And I have parentheses, so I do everything in parentheses first, and then the 8th power would be the last thing. So this is stuff to the 8th. If this was just an x, I'd use a power rule and call it good. I know that the derivative of x to the 8 is 8x to the 7, but it's not. It's a function to the h, and that's how, a function to the 8, and that's how I know it's a chain rule. So I think stuff to the 8 should be 8 times stuff to the 7, and that stays exactly the same. Okay, so I took the derivative of 8th power, something to the 8th power. And then what I need to do is, you can even keep track, do it over here though on the original function. People sometimes mess themselves up by looking at the stuff they've already taken some derivative of. So I've dealt with the 8, and what's left is a 4x plus 1. And that's back to some basic shortcut. That's just a linear function, so its derivative is 4, and you're done. And I would do a little bit of simplify here. 8 times 4 is 32, and then I have a 4x plus 1 to the 7th. Okay. So this is all really, the biggest thing here is the order of operations, picking out what shortcut to use first. And then in the chain rule, sometimes it's the little trickiest first, but I think the most important thing to realize is just that in one step of the chain rule, you should only be taking the derivative of one function. So I see 2 functions, a 4x plus 1 and an 8th power. I take the derivative of the 8th power part. I shouldn't be touching the 4x plus 1. In the next step, I completely ignore the 8th power, and then I take the derivative of 4x plus 1. Okay, so second one, again, order of operations. If I plugged in a number, I would first do the multiplication. So a square root is kind of like parentheses again. It is a grouping symbol as well as being an exponent. So we'd multiply, we'd subtract, and then we'd square root. Which means the first thing I want to do is take the derivative of square root of stuff, which remember, it's a 1/2 power, so the derivative of square root of stuff is 1/2 stuff to the negative 1/2. So don't do anything to that inner function on the first step. I'm just taking the derivative of a square root function. And then I can look back here and say, okay, now I'm done with this. So I'm just looking at a 5 minus 3x. I haven't taken the derivative of that. So I do, and it's a negative 3. And I'm done taking derivatives. So skills test, you can quit there. I don't need you to simplify at all. For exams, I would want you to try and simplify. So I'm going to make this a fraction. The 2 is going to go on the bottom, and the square root is going to go on the bottom. The negative 3 ends up on top. So I have a 2 square root of 5 minus 3x. And a negative 3 on top. And I don't care if you rewrite that as the square root or not, but it shouldn't have the negative exponent. Okay, so now I have a cosine of a cube root of x. So the 2 functions I'm seeing are the cosine and the cube root functions. Cube root I want to think of as a 1/3 power. And then order says you cube root first and then take the derivative, or then take the cosine. So we should take the derivative of the cosine first. So we want to go backwards order. Derivative of cosine is the opposite of sine. And we leave that inner function alone. Don't touch it. Now we can say, I've dealt with the cosine. All that's left is x to the 1/3. The derivative of that is 1/3 x to the negative 2/3. And I think I'm going to do the same thing, just smush this into a fraction. So negative, okay, so it's going to be a negative. On the top, I'm going to have the sine of x to the 1/3. On the bottom, I'm going to have the 3x to the 2/3. Okay. Again, skills test, I don't care if you quit here, but for an exam, I do want you to do that simplification. Last one, I have 3 to the 2x squared minus x. So if I plug something in, I do all this stuff in the exponent first, and then the last thing I do would be 3 to that power. So this is 3 to the stuff. And the derivative of 3 to the stuff is 3 to the stuff times the natural log of 3. So the 2x squared minus x will just hang out for now. And then I can say back over here, looking at the original function, don't look here, you'll mess yourself up. Looking back at the original function, I can now ignore 3 to the stuff, and I just have to focus on 2x squared minus x. I have not taken the derivative of that. So the derivative of that is going to be a 4x minus 1. And the parentheses are really important. You need to show that it's not just the 4 getting multiplied. So make sure you're using those parentheses correctly. I don't really see anything. You could rearrange order if you want, but otherwise I don't see any simplification that's going to happen. So I'm going to call that one good. All right, thanks for watching.